Hey guys, in this video, we are going to look at how you can compare linear and exponential functions when you're given a table of values. Remember that a table of values is just a way for us to see a series of points on our function, and we're going to look at how using the table we can figure out is that function linear or exponential. So in a linear function, we have to add or subtract to get the next output, right? So as we move through our outputs, we're adding or subtracting. That's what we would look at in our tables. In an exponential function, instead of adding or subtracting, we multiply or divide to get the next output. So that means that as our y's are changing, we're multiplying or dividing. So to figure out if a table represents a linear or an exponential function, we have to check to see, are we adding by a constant value every time or multiplying by a constant value every time? So the way that we can do this is just to check both ways. So we could check, what do we multiply to go between our terms, or what do we divide to go between our terms, or what do we add to go between our terms? So the first thing that you do want to check is that your x's are changing by the same amount, right? So our x's, this is changing by +1, +1, +1. Now those are our inputs. So those aren't going to tell us if it's exponential or linear, but it will let us make sure that we have all of the outputs that we need. So now if we look at our y values, let's first think about addition. To go from addition, I would do 1 plus 2. And if this were a linear function, this next change should also be +2. But when we look at that, that's actually +3. Or +6, I'm sorry. And if we look here, this is actually +12. That's not 12. +18. Sorry, 18. So if you notice, those are not changing by the same amount every time. Each time I added a different amount. So we know that this cannot be linear because we're not adding the same amount every time. So instead, let's look at what we are multiplying by. 1 times what gives me 3? Well, 1 times 3 gives me 3. Now let's look. What times 3 gives me 9? 3 to 9. Well, that's going to be times 3 again. I could also check that by doing 3 divided by 1, 9 divided by 3. I could do 27 divided by 9 is also 3. So I see that the ratio every time is the same, or that I'm multiplying by the same number every time. So because I'm multiplying by the same number, I know that it is an exponential function because I was not adding by the same number, but I was multiplying. Let's look at another example. So in this case, let's first look at what we're adding. 7 to 16, that is +9. 16 to 25 is also +9, and 34 to 25 is also +9. So I do see that my x's are changing by the same amount every time. So let's ask ourselves, how are our y values changing? Well, if we start with addition, I'm going to add 5 here, and then add 10 in our next one, and then add 20. Well, could that be a linear function? It cannot be a linear function because we are not adding the same value every time. Well, let's look at what we could multiply by. 5 times 2 is 10, so I multiply by 2. 10 times 2 is 20, so I multiplied by 2 again. And 20 times 2 is 40, so we multiply by 2 one more time. So what does that tell us about our function? It tells us that we have an exponential function because we are multiplying by the same value every time. Let's try one more example. So in this example, remember that we always start by checking that our x's are changing by the same amount every time. So in this case, we have plus 3, and plus 3. So our x's are changing the same amount every time. So let's go compare our y values. Well, I could do negative 2 to 5. If I'm looking at addition, that is plus 7. 5 to 12, that is also plus 7. 12 to 19 is plus 7. So what does that tell us about our function? That tells us that it is a linear function because the y's are changing by an added value every single time. So to summarize, if you see that when your x's are changing by the same amount, that your y's are multiplied by the same value, it's exponential. If your y's are added by the same value every time, it is linear. And that is a way to identify a linear or an exponential function from a table. Thank you.